Hello everyone, Suhail this side. Welcome back to our channel. So this would be the fourth video in the Kafka 0 to Hero series. So in the last video, what we have done, we have discussed the Kafka setup, right? So while doing the Kafka setup, we have seen both the approaches. First approach was downloading the Kafka binaries and run it from your local machine, that we have seen, right now. And this second approach which we have preferred and which we would be using throughout the series, and that was the Kafka Docker setup, right? So I have shown you the how simple is it to create the Docker image. I have shown you the Docker file and what steps I have performed in the Docker file to create the Kafka image, right? And then finally we have used the Docker Compose to bring up the Kafka cluster up and running. Now, why I choose Docker Compose, as I already mentioned, because we need to mount some of the files into the host machine. That is the reason number one. And the second reason is later on in the series, we would be setting up the Kafka cluster. So at that point of time, we would need multiple Kafka brokers running together and communicate among themselves. So that is the reason we are preferring Docker Compose. Right now, let's move forward. Now in today's video, what we will discuss different Kafka commands. So today video would be completely practical and it would be too much fun, right? So just follow the whole video and watch till the end. You will get to learn so many concepts and you will actually see how practically the data gets flown. I will show you each and every command and will show you real time data gets flowing, right? So just watch the video till the end, right? So we would be discussing the Kafka topic related commands, then we would be producing some of the messages onto the Kafka topic, then there would be consumer on the other hand which would be consuming the messages. Then we'll see the real demo, how easy it to produce and consume the messages. I'll show you both producer and consumer running side by side and we will see the messages gets flowing, right? Then we will discuss the how consumer would get the messages, either it is push based or it is pull based. And we also discuss why the kind of strategy, what kind of strategy and why the specific strategy has been chosen by the Kafka people. Then we will see the different parameters based on which a consumer can fetch the data, and we can tweak some of the parameters to increase the consumer throughput. Then we would see the serialization, deserialization and log retention and the offsets. So it would be too much detail and this video would be too much fun. Now without wasting time, let's get started. Now, so first of all, I'll go to the console where we have left right earlier. So if you see here, it is the kind of the same structure which we already have, as I already mentioned you. If I go to the Docker Compose file, the same image I would be running that I have already published onto the Docker Hub, that is the Kafka image. You can use the same image which I am using. You just need to copy the Docker Compose which I have already checked into the GitHub repository. I will mention the details in the comment section. You can just get the Docker Compose file and get the Kafka server up and running, right? So you can use the same Docker file, it would run fine. Now this was the Docker Compose. What we need to do now, we would just need to do Docker Compose up. That is the only step which we need to do. So with this, our Kafka server would be starting up. Now if you see at the end, the Kafka server gets started. So this is what we have done in the last video. Now let's see the different commands, right? So for example, the Kafka topic commands and so on, right? Now for the Kafka topic commands, firstly we have already spin up the Kafka server. Now how to, firstly we need to go into the Kafka broker. Now since we have created the Kafka container and it is up and running, let's see the container whether it is running or whether it is running or not. So the Kafka container is running fine. Now what we'll do now, we'll just need to go inside this container with the interactive mode. right? And I have given the name to this container as the Kafka name, right? Kafka container. Now we would go into this Docker container and we'll see that now if you see Kafka topics.sh, you'll see the command is running properly fine. Now firstly let's see how to create the Kafka topic. So let's see, it's very simple. For example, as I already mentioned, we need bootstrap server, right? So bootstrap server is for what? For connecting to this Kafka cluster or Kafka broker. So we have done this, right? Now for topic, we need to mention the attribute as topic, and we can mention the topic name, for example, hello world. And then at the end, we need to mention the create. So if we run this way, the topic would be created, right? Now similarly, we can create the more one topic, for example test. This would be the another topic would be created. Now similarly, we can, for example, in the e-commerce system, we have the orders event, right? Order events, right? So we can create that topic, right? Now if we see here, that topic gets created. Now if we want to delete the topic, it is very simple. How we can delete it? Just need to, instead of create, we need to do the delete command, right? Now if we do the delete, it would be deleted. Now I need to see what all topics are present, so that is also a very simple command, right? So for that, there is no need to mention the topic because we want to list all the topics which are available. Now if I do at the end the hyphen list, it would list me all the topics. Now since we have deleted the orders events, so the topics which are present is hello world and test. These are the topics which are present. Now let's if I need to see the, for example, dig more into the details, right? So sorry, not kubectl, let's, yeah. So if I need to see the more details about any topic, what I can do is we can just provide the topic name. For example, the topic is the hello world, and I can just do the describe, right? So with this we'll see that okay, this was the topic, and this is the topic ID which is getting internally used by the Kafka cluster, and this is the partition count. Don't worry about this, we'll discuss about this in the coming videos. Now replication factor, I've already mentioned, if we don't provide the replication factor if we don't provide replication factor, by default it is 1. So that is the only thing, so, right? So partition is 0. So what happens actually, whenever we are creating the topics, by default one partition gets created. So that is why it is mentioning that partition 0, because partition numbers are being created from 0 to till the number of partitions, right? Now if you see here, leader is 1. So what is 1 actually? Here is 1 is actually the node ID. If I show you the server.properties, right here, if we have seen in the last video that for every broker there are some server.properties. So for this broker, this node ID is 1, right? So who is the leader as of now? Since we have just spin up the one Kafka server, so who is the leader? The leader node 1 is the leader, right? So that is the leader, and replicas is 1. So ISR and other things which we'll come to know later when we'll set up the Kafka cluster. So now let's dig into the data directory, actually where the Kafka stores the data onto the disk, right? Now if I go again onto this, right, as we have seen in the Docker Compose, with what we have done, we have mount the temp log Kafka logs file to this data directory. Now if I go to this data directory, if you see, the hello world is there and the test 0 is there. Now what are these directories? Hello world 0 and test 0. Hello world is the topic name and test was also the topic name. And what is 0? 0 is actually the by default partition ID which has been already been created, right? Now you would ask, okay, if these are the topics, what is the cluster metadata? What is this? Okay, so this is also a Kafka topic. So when this gets used, when we have a Kafka cluster and the multiple Kafka brokers communicate among themselves, right? So at that point of time they would present, okay, I belong to this cluster, right? I belong to this cluster. So this cluster metadata gets used at that point of time, right? So this is where the data gets stored onto the disk. Now if you see, dig in further into this, now in each and every topic you see some kind of data. Now what is this? Because Kafka stores everything in binary format. No matter what you are providing, string, XML, JSON, no matter what, but Kafka always store the data in the binary format. So that is why the data is written in such a way and you are not able to see the data properly, right? So Kafka stores the data in binary format. Now we have seen the topic related commands. Let's produce some of the messages, right? Now if I produce some of the messages, how it would look like. Now, so if I see, let me just split the screen, right? Now I'll just show you. Right, now we have seen the Kafka topic command. I'll mention all the commands in the GitHub repository. I'll note down all the commands. You can refer the GitHub repository. I'll do the comment in the comment section for this. Now let's see the how we would produce the message, right? Now how we would produce the message, it's very simple actually, right? So it is very simple. How much simple? Instead of Kafka topics command, what we need to do is Kafka console producer.sh. So this is what the simple command is, right? So if we run this command, what we would get, let's see, we would get a shell. Now in this shell we would write any kind of message. For example, I write 1 2 3 4 5. Now I am writing continuously, right? So I have published few of the messages onto this hello world topic, right? Now the producer has produced the messages. Now assume this is the second application, which is the consumer actually. Now it has to consume the messages, right? Now how it would consume? There is a CLI for consumer as well. Firstly we need to go into the Kafka container, right? I'm just doing that in a quick manner. Let's go. Right now what we will do is we need to do the Kafka console consumer, Kafka console consumer.sh. bootstrap server is, as I already mentioned, it is required in mostly all the commands, because it is through this only we would be able to connect to the Kafka cluster. Right now on which topic we want to consume, right? No, it's a very simple command. Kafka console consumer, the bootstrap server, and the local host is the actually the Kafka cluster host or the Kafka broker, and from which topic we want to consume the messages, from the hello world. Now let's do this way. Now if you see, no messages are coming. We won't receive any message on this Kafka consumer. Why? But producer has produced the messages. Why we are not able to consume the messages, right? Because this is the default behavior of the Kafka. By default, what happens actually, Kafka doesn't provide the old messages, right? It provides the new messages. Now let's assume if I type now has, right? Now as, yes. Now if you see, you get all the three messages now, right? How it get all the three messages? Because this is the default behavior of Kafka. The Kafka console consumer by default doesn't consume all the messages, it consume only the new messages. Now you want to say, okay, you would argue, okay, what if we want to consume the old messages as well? How we can do that? Okay, so there is an option provided by the console consumer. In that case, that option is from beginning. There could be multiple parameters, but this is the one of the parameters. Now if I do this way, right, now you will see we get all the messages, right? Now if you see ASA, AD, so this is how we would get all the messages from the Kafka consumer. Now we have seen the producer, we have seen the consumer, we have seen, now let's see the other things. For example, if I produce messages quickly, right, now you see some of the lag. Now for example, hey, so if you see, there are some lag is there. Why this lag is there? Because to increase the throughput, what happens actually, the producer at the Kafka console producer, or at the producer side, what Kafka does is actually it batches all the messages in a for a particular time. For example, it batches, by default the time period is 1 minute, 1 second, sorry, not 1 minute. It will batch all the messages which are coming till 1 second, and after 1 second it would publish the message. Let's see again, as if you see, after 1 second only it has come. If you see one more, for example D, so if you see, after 1 second only it has come. Now there is a property also. These are the some kind of settings which generally we need to tweak in the production, that for how long we want to batch the producer records, for how long we can how much records consumer can consume the messages, right? So these are the parameters which architects, or the according to your business or according to your load on the application, you tweak these parameters. For example, I'll show you just one of the example here. For example, here if I give you timeout is equal to 50, let's assume this is the parameter, right? Now if I produce the timeout, so if you see, now what I have done, no, it is in milliseconds. No, the producer would just batch the records coming till 50 milliseconds. Let's assume Y, right? So if you see, right, it is coming quickly, much faster, right? Now why it is much faster? Because we have tweaked these parameters, right? So these are the parameters which architects generally tweak according to the application load, right? So that's what was the producer consumer, right? Now let's see more what we want to discuss. We have seen the Kafka topic commands, we have seen the producer consumer, we have seen the demo, we have seen the producer and consumer both running side by side. Now let's discuss the concept of push versus pull. Now for example, let's assume this is the Kafka server, right? This is the Kafka broker where producer is producing the messages, and this is the consumer. For example, it could be your application, or it could be your any kind of application actually. So in the application you have client library, as I already mentioned in the second video, and in this application we would be using the Kafka client library internally, which would be publishing the messages onto this Kafka broker, right? Now you would say, okay, now producer had produced the messages onto the Kafka server. Now how would the consumer would get the messages from the Kafka server? So is it push based or pull based? Push based, we say push based when the Kafka broker actually gives the messages to all the consumers, so that is a push based. And pull based, when we say pull based is actually when consumer itself goes to the Kafka server and gets the record one by one. So that is a pull based, right? But now Kafka guys, what they have chosen pull based approach. Why? Because imagine for example, producer could be thousands of producer, right? Producer could be millions of producer. The messages keep getting onto this Kafka broker, right? Now if let's assume if Kafka broker would try to publish or would try to push the messages to the each and every consumer, so it is not sure the kind of message rate which the producer is producing, the same kind of processing would be happening at the consumer or not. This is not sure, right? So due to this, to isolate the workload so that messages can be produced independently at the producer side, and consumer can also process the messages at its own speed. So for that purpose, Kafka guys has chosen the pull based approach. Now you would ask, okay, now if this is pull based, how does Kafka console consumer or Kafka consumer would consume one messages one by one? No, I did not say this. I am saying just it is a pull based. Now as we have seen, producer is batching the messages at the producer side for 1 second. Similarly, at the consumer side also we have a max poll records, right? So that is a property called, for example, this is a property called max.poll.records. So in a single poll, how many records you want to poll, how many records you want to fetch. For example, you want to fetch 50 records. This is also one of the crucial parameters which architects tweak according to the business application load, right? So in a single call, how many messages would be consumed by the consumer? In this case, that is 50, right? So this is how to increase the throughput and to match the consumer processing speed. That is how the Kafka guys has chosen. Now let's discuss serialization and deserialization. What is serialization and deserialization? Okay, now as we have seen, let's see it again. Now if you see, right, if you see, we have seen here, for example, this is the topic, right? Now we have seen here the data gets stored in the binary format, right? Now you would say, okay, but my application has produced the certain Java object or certain XML object or certain JSON file or JSON format. So but no matter what you are doing or what you are producing, in which format you are producing, Kafka will always store the data in the binary format. Now where does the serialization and deserialization comes in picture? The serialization would come in picture at the producer side and the deserialization would come in picture at the consumer side. Serialization would in the properties only, while we will be publishing the messages onto the Kafka broker, we would pass the serializer, right? That this is the object, and then the Kafka client library would convert this particular object into the bytes. And similarly on the consumer side, we would mention the deserializer, that this is the, for example, some Pojo class is there, we would just mention that this is the deserializer class against which this bytes data should be converted, and based on that the consumer get the proper response object. So that is how this serialization and deserialization comes in picture, right? Now let's discuss more. Now since you say, okay, now Kafka data gets published onto the Kafka, does Kafka stores the data forever or for how much time? No, there is a property for this. Let's see what is the property actually. I would just show you here, right? So I'll just show you here. For example, if I go to the Kafka config and if I do the server.properties, so if you see here, so there is a log retention hours, right? So log retention hours is 168 and log retention bytes, right? So 168 hours is equal to 7 days. So by default what happens is Kafka stores the data for 7 days and or the bytes. So first one means whichever comes first or whichever gets criteria gets filled first, according to that the Kafka broker would delete the older messages. So this is where the Kafka retention policy would come. Now let's discuss more on the Kafka offsets, right? Now what is the offsets and why it is important, right? Now what happens is actually, so the producer is there who is producing the messages and the consumer is here who has consumed the messages, which we have seen in the demo. Now producer is producing the message in the continuous fashion, right? And consumer is also getting the records, for example 50 records at a time, right? Now you would say, okay, so producer is producing the messages, but these messages by default, as we have seen that by default one partition has been created if we don't mention the partition ID. So assume this is the default partition, that is partition 0, right? So by default all the messages would be stored in this particular topic partition, right? And now you can visualize this as a array like data structure. For example, it also starts from the 0 index, right? So offset is nothing but a number which is actually representing that up to which point the consumer has consumed the message, right? For example, this consumer has consumed this consumer max poll records, for example, we have set is equal to 2, right? So in the first poll, right, so consumer what would do, consumer would consume the 2 records. So once as and when consumer consumes 2 records, what it will said, it would send the acknowledgement to the Kafka. And what Kafka would do, Kafka would increase the offset number, right? Offset number. Kafka would increase the offset number by 2, that this number has been increased, so that next time when consumer would ask more messages, it can give, for example, the next iteration in the second poll. What would happen in the next poll? In the second poll, the consumer would retrieve the messages from the second index, right? From the second index, right? So this is how actually the offset works. So it stores the data in the particular order. So as and when the producer is producing the messages, the data gets stored in the order. So so it is off with offset, it is just guarantees that consumer will get all the events or messages in the order as it has occurred. So as and when the consumer consumes the messages, the offset keeps on increasing, right? Now if you want to see the offset as well, that what is the offset number, for example, I'll show you there as well. For example, this is the one. Let's assume this is the one. For example, I'll just start the producer again, right? And I'll just start the consumer again. And what I'll do is I'll just do the property print dot offset is equal to true, right? So I'll just do this way, and I'll just start the consumer, right? Now let's produce the message hello. So if you see, the offset is currently 41. Now if I do the hi, if you see, offset has been increased to 42. If you see by, if so, the offset keeps on increasing. So this is where the offset comes in picture, right? So offsets are very, very important. So it is working by default. This, you can assume this is a partition 0, which for every topic, which the partition we have already seen. For example, this is the data folder, and in this data folder, that this is the partition, the hello world, this is the 0 partition. And you would ask, okay, then what is this consumer offsets? This is also a topic which we would discuss later, right? Now let's move further. What else we need to discuss? I think that was all I want to cover in this video. In the next video, we'll see the real case when we have multiple consumers for the same topic, and we'll see how it behaves. Then we'll see what is the importance of consumer groups and why there is a need of it. Then we will discuss about partitions, why partitions, what is the importance of it, why we need more partitions. We'll go more in depth from now onwards, right? So that was all from today's video. So if you really like my explanation, please do like, subscribe, and please do comments in the comment section, because it would keep me motivated to publish the video, the next video more fast, right? So thanks a lot. That's all from this video. See you in next video.